In this video, we'll be building our foot rig. In addition, we'll be mirroring the parameters and all of the nodes for our left leg and left foot over to the right-hand side. So a quick overview of the foot we'll be building. It's a simple FK foot, but has what's called a reverse foot setup. And basically that allows us to, a simple set of sliders, can roll the foot back on its heel and then forward, bending at the toe, and then raising at the toe. And then we have individual controls for the heel offset, the ball offset, the toe pivot. We have a heel twist. We have a toe twist. We can move the foot side to side. And then we can rotate the toe. That's what we'll be doing. To start our rig, we'll begin very much as we have in the past. Going to turn off all of the, let's see what we got here, spine, there we go. Turn off all of that, turn off the left leg proxy and controls, and then I'm going to turn back on that soldier body that we had. And in the right-hand viewport, we'll draw some bones. Bones tool, I call this left foot. No kinematics, and the placement is going to be view-based. And we can turn our leg bones back on, just so we know where we want to start our foot bones. So 2 bones, one from the ankle to about where the toes should pivot from, and then one at the tip of the toe. So we can start down to about, I think about here, and then out for the toe. Our new nodes, escape out of the bones tool, back into a perspective view. And it looks like we got this almost exactly right. So I could leave this here, or I could take this bone or left foot root 1. I could turn off keep position when parenting, and I could move it to the tip of that bone. But I think I got it pretty close, so I'm going to leave it the way that it is. However, I am going to straighten out that toe. You can see that the foot bone comes along and then the toe kind of bends a little bit. So to do that, extract the pre-transform. The rotations I want to get rid of are the Z, I think. Let's try it. There we go. And that's fine. You don't need to necessarily be straight with the toes because we're aligned generally with the foot. So that should be pretty good. And in your testing, you may find that the placement needs to be adjusted. And you can very easily do that just by going back into the bones tool and selecting this little guy, and you can move that around if you need to. But I think this is going to be good for me. As I've mentioned earlier, this character is actually wearing a big army boot. So rigging just the foot like this may not work when he's got a boot on. But I can go back and change this once I add the boot back in. But for now, this is great. So rename these, take off the 1 on each of these nodes, make that a space. And then just as we did with the leg bones, I'm going to add the proxy geometry, and then we'll make FK controls for these. So I have that proxy geometry already built here. Turn off soldier body. So I have a left foot proxy, which I can parent in to the left foot bone. I go inside, you can see that I have an object merge pointing to soldier body and pointing to that foot group. And then the out node, I'm going to control click on the lock, and then toes to foot bone 2. Again, soldier body group is toes, control click on the lock, and now I've got my proxy. So select my foot bone, control click on our FK control, left foot bone 1, that's fine. Select foot bone 2, control click on our FK control, resize our control objects, make this one a little bit bigger. That should be good. And then as we did before, I'm going to constrain the rotation of the foot bone to the foot control, foot bone 2 to the toe control. So constraints, blend, simple, just rotation, keep position after. So foot bone 1, foot bone 1 control, dumps us into the constraint network. And then blend again, simple, just rotation, keep position after. And there we go. So now when I select that control, I'm rotating the foot, and I'm rotating the toe. Left foot bone 1 control will have its offset parented to the foot root. Left foot bone 2 offset will be a child of the left foot bone 1. So now when I rotate this one, it will also rotate position of the toe rotation. Our left foot root, we're going to constrain to this lower leg bone. So we can come over here, parent blend, simple, full transform, keep position, left foot root, and lower leg bone. That dumps us into the left foot root constraints network. Go back up to the object level. So now if we turn our controls back on, we select that IK control, our foot moves with the leg. And if we turn on rotate for that ankle, nothing will happen. In order to have our ankle IK control rotate the foot, which currently it doesn't, because these two bones are being controlled by the FK control. What we can do is add single bone IK to the foot bone and to the toe bone, and then use those goals that are created as children of this rotate control. So that will achieve a rotation of the foot via this ankle IK control. So to do that, we're going to go back into the Bones tool. We're going to select IK with Twist Effector. I'm going to right-click in the empty area. I'm going to say Add Kinematics. And then we'll select the left foot bone 1 as the first bone of the chain and accept selection. And then we're going to select it again as the last bone of the chain. So as before, we get a couple of new nodes. An IK solver has been added to the kin chops network. So I'll escape out of the Bones tool. Currently, just as we had with the leg and with the arm, these bones are being controlled by the constraints. So we need to blend that constraint off, but we need to figure out what to do with this twist. With a two-bone chain, it's kind of easy to find out where to put this twist control. And you're going to put it in the direction of this angle. So we put it out over here. But with a single IK, it's hard to know, whether this should go up here or down there as a default. So the easiest way to figure that out is to just grab it and move it. So we're going to move it up, just straight up on that same plane as the bone is on. And then we can go to the constraint, and on the blend, we can just blend it off and watch what the bone does. If this is on the correct side of the bone, then nothing will happen. But if it's on the wrong side, then we'll see that bone spin around in order to twist properly and point to the twist control. So if we blend that off, we can see, in this case, the bone needs to twist all the way around. So we'll put the constraint back on. We'll go back up to the object level. Take that twist bone, and this time, instead of going above the bone, we'll just drag it below. And it doesn't really matter where you put it. You can put it just somewhere here. Now we can go back to the constraint. And when we blend this off, the bone stays right where it is. So that's what we want. And now we're going to do the same for the left bone 2. So back into the Bones tool, right-click, Add Kinematics, and the type that we're adding is IK with Twist Effector. Left bone 2 is the first bone of the chain. left bone to second bone of the chain. So we have this exact same situation. And again, we want to move this in a direction. And I'm pretty sure that down is the right one for this guy. So we can move it down and then go to that constraint and blend it off and see what happens. Yep, so that was right. So in both cases, we want this twist to be below the bone. And now for these two twist constraints, they're really big, and I mean, we're not really going to be using them very much, but let's just do the same as we did before. We're going to make them smaller, turn off shaded mode, can make them even smaller than that. And then we're going to turn off their selectability and visibility. I'm going to grab their, extract their pre-transforms, get rid of the rotates, we turn them back on again. So now they're in line with the world and just directly below the bones that they're associated with. So we can turn those back off. So now we want to bring this IK-FK blend and use it to drive our constraints. So we'll take the simple blend, drop that in there, and again we want to negate it. So 1 minus. So when this blend is in IK mode, the constraint is off. We'll copy that. Do the same for our toe bone. Great. So now if we are in FK mode, we can move these bones around. And if we're in IK mode, the constraint does nothing. And this guy still does nothing because the goals and the twist nodes are sort of free floating. They're not part of our IK hierarchy. So we'll fix that next. We're going to add the left foot bone goal and twist nodes to our IK hierarchy. But before we do that, we're going to be adding some additional nodes to give us the foot roll and twist and all of those things in our reverse foot setup. But we can test to see if this is going to work just by parenting all of these nodes that have keep position when parenting on just directly to our IK control. So now if we select that, you can see that it's rotating the entire foot. So that's exactly what we want. But for now, I'm going to break those connections because we're going to set up the reverse foot. The reverse foot setup relies on a series of nodes that are arranged in a hierarchy that provide different pivot positions for our foot. So to start, I'm going to turn off the selectability and display of our goals and move these guys down. And I'm going to set up a series of nulls, and then I'm going to place them where those rotations need to happen. So to start with, I'm going to have a left heel location, and then I'm going to have a left foot outer location, left foot inner location, left toe end location, left toe location, and a left ball location. So all of these, I'm going to color them blue just to make them distinct from the other nulls. And I'm going to make them quite small. So left heel location is going to be at the left heel. And again, this guy is going to be wearing a boot, but just for this tutorial, I'm going to put this in a location as if he were standing on the ground. It's easier to understand that way. So I'm going to put this at his left heel, right about there. So when we use that left heel control, this whole foot is going to rotate from this position. So it's going to rotate up like that from this heel. And then left foot outer is for that side-to-side motion. So I'm going to put that around about the widest part of the foot, right around there, something like this. And then the left foot inner, I'm actually going to parent that, keep position when parenting, and then break that connection. Extract that pre-transform. And then I'm just going to move it straight over. So the outer and inner are going to be directly across from each other. Left toe end is going to go at the end of the toe. Something like that. Left toe is actually going to go right here at the root of the toe. And the left ball is going to go right here also at the root of the toe. So these two, I'm going to parent to left foot bone 2, and that will pop them right to that position. Now I can turn on keep position when parenting, cut that relationship, and I can extract their pre-transforms and I can get rid of their rotation. Great. So these will be the locations that we're going to rotate the foot from. And all of these are going to be above in the hierarchy of our goals. So as we rotate any of these nulls, they're going to rotate the foot bone goal and twist and the toe bone goal and twist. They'll also be a parent of our leg bone goal, which currently is a direct child of our IK. But we're going to reparent this guy below these reverse foot controls. And then all of this is going to be parented into the IK. So we'll have, as we move our IK control, it will move all of these bones, and then below that, we'll be able to rotate from these different positions. So we'll do that next. So the hierarchy we're going to make is essentially in this order. The toe and ball are going to be in the same level. But let's move this leg bone goal aside for a second. We're going to take our left heel location, and we're going to grab all of these actually, and make sure that keep position when parenting is on, because we've established their locations, and now we just want to rearrange them in the hierarchy. So we'll take left heel location, make it a child of the left leg IK control. And then left foot outer location is a child of a left heel. Inner location is a child of the outer location. Toe end is a child of the inner location. And then both the left toe location and the left ball location are children of the toe end location. And then as a child of the toe, we're going to put both the foot bone goal and the toe bone goal. So we'll take both of these guys. Let's rename them to left foot bone goal and left toe bone goal. So both of these keep position when parenting is on. Make them children of the left toe location. And then the twist for both of those, for the foot bone and the toe bone, again, we'll rename those left foot bone twist and left toe bone twist. So both of these keep position when parenting is on. Parent both of them to the left ball location. And then we want to bring this left leg bone goal, which was here, we want to make this a child of the ball, like so. And what that's going to create is a hierarchy where if I move the left leg IK control, it's going to bring with it all of these nulls that we've made, and they're going to bring all of the goals and twists that we've made. So this guy is the parent of everything. And then if we go down the hierarchy, now we have this left heel location, and we're not going to transform it, or rather we're not going to translate it, but we're going to rotate it. So it's going to stay in its position, but it's going to rotate everything else. And you can see that everything rotates. It moves all of its children around its position. And then the outer is, again, not going to translate, but it's going to rotate. And when I rotate it up, see that it bends that ankle. And then the same with the inner. And then the toe end is at the tip of the toe. So when I rotate it, it's going to move that ankle up. And the toe location will do that. And the ball location will do this. And that's the reverse foot setup. We're just going to clean up our network a little bit, and then we'll work on the parameter interface, and we're going to drive all of these things with very simple expressions. So after doing a little bit of testing, I found that instead of parenting both the toe bone twist and the foot bone twist to the left ball location, I found that I got a little bit better behavior if I parented the left toe bone twist to the toe location. So now these behave a little bit better. I get a nice firm toe here when I'm rotating from the ball of the foot. So I'm going to turn off these goals and the twists to make it a little easier to see what we're doing. And let's drive our foot controls with this IKFK blend, just as we've done with the leg and arms. So I'm going to go up and find the left leg bone 2 control, which is the FK control here. I'm going to steal this expression. I'm going to put that inside both the left foot bone 1 control and the left foot bone 2 control. So on their render tab, display, paste that in. And I'm going to change left leg to left foot. Even though this parameter doesn't exist yet, I can still use it. And here, if I open that up by Alt-E, yeah, so it's not liking the parameter reference, but this will be valid in a moment once we create the parameter. So just like the arm and the leg, I'm saying if the left foot control display is 1 and the left foot IKFK blend is less than 0.5, actually that should be leg. There we go. So if the foot display, which again isn't created yet, is 1, and the leg IKFK blend is less than 0.5, then this should be 1, otherwise it'll be 0. So that's all we need to do for those FK controls. And again, this error will go away once we create this control. So go in our type properties, go down to our left leg, and inside our left foot folder, we're going to copy these 3. You could use these 3 to also drive the foot if you wanted. I'm going to create them separately. So just quickly rename these foot. So you can see as soon as I hit apply, that warning went away, because now this is a valid channel. All right, so for our reverse foot controls, we're going to need a series of float parameters. And the first one we need is called left foot roll. And this parameter is going to have a range of -10 to 10. And then the next one we need is left heel offset. And this one is going to go from 0 to 10. I'm going to lock those off. Should lock this one off as well. And in case you're not aware, locking this range will prevent the user from inputting any value beyond this range. Whereas if it was unlocked, then the parameter here in the parameter pane would just show, in this case, -10 to 10, but the user would be able to put in any value they wanted. But for this reverse foot, we want just the values that are there. So left heel offset. Next, we need left ball offset. And that one again is 0 to 10. Left toe pivot. And this one again, 0 to 10. Now we need left heel twist. And this one is from -10 to 10. Left toe twist. -10 to 10. Left side to side. Again, -10 to 10. And finally, left toe rotation. -10 to 10. Apply that. So there we go. So we have a left foot roll from -10 to 10, heel offset, ball offset, toe pivot from 0 to 10, heel twist, toe twist, left side to side, and left toe rotate, all going from -10 to 10. And then we're going to use these to drive these rotations that we've created with this new hierarchy. Rather than have you sit there and watch me fill in all these expressions, I've gone ahead and hooked up all of these parameters to our nulls for our reverse foot. And what I'll do is just walk you through what I've done and give a little bit of explanation as to what these expressions are doing. So if we look at our blue pivot nulls, we're going to set aside foot roll for the moment. But if we look at left heel offset, what we want it to do is, when it's at 0, the foot is flat on the ground. And when it's at 10, so from 0 to 10, we want the foot to rotate back from this position. So we want it to do that. So that's simple enough. We have a parameter going from 0 to 10, and then we have a null that we want to rotate back in X. So using Alt-E, I can bring up the expression editor. We can see that entire thing. So ignore for a moment this left foot roll and look just at this fit expression. So we're saying left heel offset is the value that we're fitting, and its minimum is 0 and its maximum is 10. And we want to fit that between 0 and 50. And 50 is just the amount that I found just by manually selecting this node and rotating it back on X until it reached a point that I was comfortable with. So that's why I chose 50. And so this part of the expression is controlling this action. So simple enough. And then for the ball offset, I did exactly the same thing. I took this ball node and I rotated it forward in X, so I lifted the heel up by an amount that I was comfortable with. So I rotated it to about there. And so this value I used in the expression. And you can see ball offset here. And then most of what's going on here is the foot roll is a combination of the heel offset, the ball offset, and this toe pivot. And again, this toe pivot is just me selecting this null, rotating it an amount that I was comfortable with, and then fitting that amount between 0 and 10 and driving it with this parameter. So the foot roll is a combination of these three, and they need to happen at slightly different values from -10 through to 10. So from 0 to -10, I'm doing exactly the same thing as heel offset 0 to 10. So the null that drives that heel offset is driven by this heel offset parameter and the left foot roll parameter when its value is from 0 to -10. And we can see that again here. So this null will rotate in X depending on two parameter values, the left foot roll parameter and the left heel offset. The left heel offset is going from 0 to 10, driving 0 to 50, and the left foot roll is only active from -10 to 0. And then I just continued on. You can see if I select one of the side-to-side ones, this left foot outer, I open that one up. Again, it's exactly the same kind of expression. I'm taking the side-to-side parameter, and I'm saying from 0 to 10, give me 0 to -50 in rotation. And then for the inner, I'm saying side to side, -10 to 0, 50 to 0. So that gives me 0 to 10, and from 0 to -10. And then the toe rotation is just this one. And again, this value of 60 is just one that I picked, and I can change that at any time. And then the toe twist, I just picked a rotational value. So when you look at something like this in a tutorial like this, it might seem like there's a lot going on and it's really complex, but it really isn't. It's all using the same style of expression. This fit. So we're taking this parameter value between a certain range, and then we're fitting it to rotational values and applying those rotations just to various nulls at different points in the hierarchy. With that done, I'm going to select all of these nulls. I'm going to turn off their selectability and their display. And I'm also going to use our lock all script to lock all of the other parameters except those ones that have the expressions. So it looks like our left leg is done. So we have our parameters for display of both the leg and the foot. We have our foot roll all set up. So now we just need to promote a couple more parameters from our foot into our parameters. And that will be that. And then right after we do that, we'll mirror this whole setup from the left side to the right side, just as we did with the arms. So the parameters that we need to promote are for the foot when the leg is in FK mode. We have these two controls, so let's promote those right now. Go to our type properties. So left foot bone 1 control. Let's place that right in the middle there. And we're going to call this left foot bone 1. And left foot bone 2 control. We can copy that. Hit apply and accept. Now we have our full parameter pane for our left leg. All right, I'll pause the video and I'm going to go through and just clean this up a little bit, organize the network, place it into a net box, make sure that any nulls, like for instance this left foot root, should have its selectability turned off and its visibility turned off. Bone selectability should be turned off, things like that. And then I'll come back and we'll mirror the leg. So I've spent a few minutes going through all of the nodes that we've made for our left leg and left foot, making sure that everything is named correctly and that every node that should not be displayed or selectable has been turned off. I've also gone through and locked out all of the parameters that should be locked. And on the goals and twist objects, I've locked all of their parameters, just in case they get selected somehow and moved around. And then I put the left leg into a net box and the left foot into a net box. So now we're ready to mirror, and we're going to start as we did before by mirroring the parameters, and specifically this left leg folder. So we select our HDA, we use our mirror HDA parameters shelf tool, and it asks us for the folder to mirror. And in this case, we want left leg. The original prefix is L, and the new prefix is R, and there we go. So now if we look at our parameters, we have our left leg, and we have a right leg. So the only thing we need to change is this left spelled out should be right. So I'll quickly go through and find that. And you'll notice that in this particular case, this folder name is still left. And that's because our script doesn't really play well with folders, but the folder name is usually something that Houdini takes care of internally in order to switch between the folders while you're selecting objects. So we could change this or we could leave it. I'm going to leave it, it's fine. There's no harm in this particular case having left. But all of my other parameters have been changed, so we can hit accept, and there we go. So now we'll dive back in, and now we'll mirror all of our nodes. So I'm going to select them, and then in the viewport, I'm going to type mirror. Oh, it might want me to select them again. There we go. So we've selected all of our left leg nodes. We haven't selected in the viewport because we want all the nodes, including the ones that are hidden. And we can see that we're getting a preview of what our result is going to be. Our new prefix is R underscore, and we're removing the old name up to underscore. So we can right click and accept. And again, just as we had in our arm, it looks like one of our constraints hasn't updated, but that's fine. So I'm going to hit escape in the viewport to get out of the mirror tool. And then in the network, I'm going to grab the left leg and left foot net boxes and move those over to the right-hand side. So now I just want to go in and double check all of my constraints. So I'm just going to update that offset. And then it's this foot that we need to update. So there we go. So that is pointing over there. So I'm going to pause the video and track down why this is still pointing over this way. I think I know what it is, but it might take me a minute to find it. Okay, I'm back, and I've tracked the issue down to something that I can't really explain adequately. You'll remember that we have, on our left-hand side, we have the foot bone goal, the toe bone goal, toe bone twist, and the leg bone goal, as well as the foot bone twist. And these are all the very bottom children of our foot setup. But for some reason, when I mirror them across, so here we have the right-hand side versions of those nodes, they're still sitting over on the left-hand side, even though their parents are over here on the right-hand side, where they're supposed to be. So that's kind of a strange little mystery. So I'm just going to take all of these, just going to translate them over to where they're supposed to be. And I'll pause the video and get exact numbers, but that's a fix. I'll have to investigate why that happened. It might just be one of those things, a little bug somewhere, maybe in this particular build. But if something like that occurs, it is easy enough just to fix by manually moving them over to where they're supposed to be. I'll fix that and come right back. All right, I've made little adjustments needed to get those goals back where they're supposed to be. Now we can use our OpChange shelf tool to change all of the channel references from left to right. So again, we'll select all of our nodes, OpChange. We want the old string to be left underscore, the new string to be right underscore. So bring up our parameters. For our left leg, we know that it works. We just quickly check the foot roll. That works. Go to the right leg, foot roll, works perfectly. Heel. So all of these will work fine now. So we are finished our rig. I'll just turn all this stuff back on so we can see what we're doing. There we go. So in the next video, we'll talk a little bit about adding some scripts to our parameter interface here on the master tab and on some of these other tabs. We won't do many of them. We'll just do one or two to show you how you can create a script here on your parameter pane that will drive a bunch of other parameters. One of the most useful ones is a little button that says revert to defaults. So if you've animated your character and it's in a particular pose, but you want to get it back to the default pose, you can just quickly click one button and everything will return to normal. So you can put that on the master tab for everything, but you could also put it on each of the sections of your rig. So if you wanted your left leg just your left leg to return to defaults. You could have a button to do that. And that's what we had if you remember, our actions folder in each of our sections. That's where those buttons will go, in the actions folder. Additionally, we'll make one that will key, for instance, key the entire left arm. So that's a quick way of isolating animation. Instead of keying the entire character every time, you can just quickly make an adjustment to the right leg, key the right leg. So when we come back, we'll do that. In addition, we'll do something a little more efficient with our proxy. Right now, our proxy objects are inside geometry objects, and we've object merged from that original soldier body into a null, and then we've locked it. So this geometry is actually sitting inside this node right here. And that's not great. It makes your file size bigger because the node is sitting in your HIP file. And it's also not very procedural. So what we're going to do is we'll use a quick script that will let us select all of these proxy objects. And then the script will dive inside and find this node and get the geometry that exists inside this node. And what it will do is it will take that geometry and inject it into our HDA here in the extra files section. So we'll have a big list of those proxy objects in our HDA. And then inside of our proxy objects, we'll get rid of these guys and we'll put down just a file in node. And the geometry file parameter will point to that section. And these, when you add something to the extra files area, they're called sections. So we'll have our proxy objects as sections, and then inside our proxy geometry nodes, we'll have a file that will point to those objects. So that'll be a little bit more efficient. So we'll do that in the next video. But for right now, our rig is finished and it's ready for an animator.